Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at a Japanese mathematical Olympiad question that was proposed to us by one of our YouTube subscribers from Japan who actually left our country for further studies. So if you're just joining us for the first time, endeavor to like, share and subscribe to the channel. After subscribing, make sure you turn on your notifications so that when subsequent Olympiad questions are uploaded, you'll be notified to come and watch. Again, I'm going to be solving this problem with two different methods, and if you have an alternative method from the two methods I'm going to be using, feel free to send me your proposed solution and I'll be very glad to make a video and give credits to you because learning never ends. So guys, if you're joining us for the first time, like I said, don't forget to subscribe to the channel. So let's dive straight away into what we have for you today. Okay, so the objective of the question is to get the value of x or the values of x, provided x solves this equation, the sum from n equal to 0 to 5 of x to the n equal to 0. Okay, so the first method I'm going to be using is, okay, let us just sum. Okay, so let us just apply the sum. So when n is 0, I have x to the power 0. When n is 1, I have x to the power 1. When n is 2, x to the power 2, right up till when n is 5, x to the power 5. So I'm going to sum all the terms of the sequence x to the n to get my series. So, and I equate to 0. So I'm going to have x to the 0 plus x to the 1 plus x squared plus x cubed plus x to the power 4 plus x to the power 5 equal to 0. Now x to the power 0 is 1, while x to the power 1 is x. So we have 1 plus x squared plus x cubed plus x to the power 4 plus x to the power 5 equal to 0. Basically, we clearly see that x cannot be 0. Okay, x cannot be 0 because n is definitely 0 and 0 to the power 0 will not exist. So x here will definitely not be 0. Now, having this in mind, this is what I'm going to do. I'm going to allow 1 plus x, then from the next two consecutive terms, I'm going to factorize the term before the second term. What I'm saying is that from x squared plus x cubed, I will factorize x squared. I'll be left with x squared. I'll be left with 1 plus x, because factorizing x squared from x squared, you have 1. Factorizing x squared from x cubed, we have x. Now, from the next two terms, I'll still factorize x to the power 4, and I'm going to be left with 1 plus x still. Now, you realize that 1 plus x is common in kind of these three terms. So factorizing out that 1 plus x from the first term here, from the first grouped term, you're going to be left with 1. From the second grouped term, you're going to be left with x squared. And from the third grouped term, you're going to be left with x to the power 4. Now, if the product of two quantities is 0, either of the quantities is 0. So it means that 1 plus x will be 0, or 1 plus x squared plus x to the power 4 is equal to 0. Now, clearly, this is a quadratic equation whose variable is x squared, and the discriminant is 1 minus 4, which is negative 3. Discriminant being less than 0, it therefore means that they are complex roots. But I'm not going to pass through that methodology. I'm going to do something unique. This is a mathematical Olympiad question, so I will try to do something else. Now, we know that for every value of x in a set of real numbers, if I take x to an even power, the result is always greater or equal to 0. Okay, so but I'm also introducing 0 because x can be 0 since x in the set of real numbers. This is just a general principle, not definitely talking about this question, because we already said that x cannot be 0. But for any value of x in the set of real numbers, once you raise it to the power an even number, it is going to be positive as well as it can be 0 provided the x is 0. So it therefore means that even x squared will also be positive. So if I add two positive quantities, the result will also be positive or 0 provided the quantities are all zeros. Okay, so if I add 1 on both sides of the equation, you realize that the left hand side will be 1 plus x squared plus x to the power 4, and the right hand side will be 1. In fact, if I take 1 plus x squared plus x to the power 4, the result can never be 0. The result will always be greater than 0, or greater or equal to 1. Okay, so we cannot add two quantities that can be 0 to 1 and the result is still, and the result and the result eventually one day becomes 0. It's impossible. So this quantity here is always positive for any value of x you take. So it therefore means that this 1 plus x squared plus x to the power 4 equal to 0 cannot be solved in the set of real numbers. Alright, so I'm just basing myself on, okay, x is in the set of real numbers. Alright, so I'm not solving the set of complex numbers, I'm solving the set of real numbers. So like I said, the discriminant was negative, so the variable x squared will never be real. Definitely x as well will not be real. So this is just a little explanation in an alternative method. So from here you realize that this quantity is equal to 0 provided 1 plus x is equal to 0, and 1 plus x is 0 if x is equal to -1. So that is the only solution, that is the only real solution to the equation, the sum from n equal to 0 to 5 of x to the n equal to 0. We can try. 1 plus -1 is 0. -1 squared plus -1 cube is 0, because -1 squared is 1, -1 cube is -1, 0. -1 to the power 4 plus -1 to the power 5 is also 0. 0 plus 0 plus 0 is 0. Now in the alternative method, we are going to realize that, okay, we are summing from n equal to 0 to 5 of x to the n. X to the n is a geometric series, all right, an exponential function. So definitely it is going to have a first term and a common ratio. So, or if we just look at it here, we realize that x over 1 is x, x squared on x is x, x cubed on x squared is x, and so on and so forth. So you realize that this is, you're summing the terms of a geometric progression whose first term is 1 and whose common ratio is x. So the sum of the first 6 terms, because you are summing from n equal to 0 to 5, so there are 6 terms because we have 1, 2, 3, 4, 5, 6. So the formula says we need to take the first term into 1 minus a common ratio to the power the number of terms over 1 minus a common ratio. My number of terms are 6, so when you see 5 here, don't go and replace here with 5. You replace the n here with the number of terms, and there are 6 terms. If we started from 1 to 5, there are going to be 5 terms. So in this case, I'm going to precise that x cannot be 1. In fact, x cannot even be 1, because if you replace x with 1 here, the equation is going to be false. So x cannot be 1. So we are still working in a domain of definition of this function here. So since x cannot be 1, then we can cross multiply by 1 minus x, because 1 minus x cannot be 0. Alright, so cross multiply by 1 minus x will be left with 1 minus x to the power 6 equal to 0, which means x cubed all squared is equal to 1. Alright, and if x cubed all squared is equal to 1, it therefore means that your x cubed will be equal to -1. Normally, x cubed is equal to plus or minus 1, but since x cannot be 1, then we just have x cubed equal to -1. Now, what's the value of x? Is a cube root of -1, or in fact, a number that when you cube it, you're going to have -1, and -1 is the only number that does the job. So the value of x is equal to -1 in the first method and in the second method. Thank you guys for watching. See you guys in the next video. Make sure you tell me what you feel about this video. If you have an alternative method of solving, try to get to me, and I'll be very glad to follow your procedure and upload a video so that viewers can learn from you and give credit to you. Thank you once more, and again, if you have a question, if you have a very difficult question which you have difficulties in approaching, you can send them to me. I'll try to work on them, and I will upload a video so that everyone can learn. See you guys in the next video. Until then, stay blessed.